All right, let's solve some trig equations. So first of all, here's an example that says, let's solve sine of t equals 1/2 for all possible values of t. The ticket here is the word all. So what we have here is a graph now. You can see that here's our sine function. And we want to know where that is equal to 1/2. So that would be this guy right here. Okay, so you can see, well, there's one. Oh, there's another one. Look at all these values where the sine function is equal to 1/2. Okay, well, we know if we want to get those values, we know that if we use our unit circle, if the sine is 1/2, that's the y value. So that's up 1/2. That means that we've got this value and this value. If you think about this is our unit circle now. So the sine is 1/2, and that would be pi over 6 and 5 pi over 6. Well, those are right here. Let's do blue. Look, this looks like, so pi over 6, if you think about that as a decimal, that's going to be 3.14 divided by 6. That's going to be this guy. And 5 pi over 6 is really close to pi. That's this guy. But we also have to get all the rest of these. So we're going to get the angles that are coterminal. So we're going to take pi over 6, which is this one, and we're going to add a whole circle around it. Let me do this in red. We're going to take pi over 6, but we also want to get this one, which is pi over 6 plus 2 pi. Okay, going around this circle, coterminal angles, go back to our first section. Well, then we need to also add another 2 pi and another 2 pi forever and ever, because this is a periodic function. So we're going to say, here's a nice way to do that. This would be add 2 pi times 1. This would be, together, would be add 2 pi times 2, 2 pi times 3. So what we do is we say, well, we're going to take the answer, and we're going to add 2 pi k, which means times it by however many times you want. Matter of fact, times it by -1, because then you'll get these guys back here. All right, we'll get this guy, we'll get this guy, so now we're getting just these values, but we're getting all of them. Okay, that one for that matter. Okay, so the first answer is going to be pi over 6 plus 2 pi k. Now we need our 5 pi over 6. So let's go with 5 pi over 6. But we also want not just that angle, we want all the angles that are coterminal. So instead of writing it all out like that, I'm just going to put plus 2 pi times k. So the answer, and that is when they want all possible values of t. So my answer would be pi over 6 plus 2 pi k and 5 pi over 6 plus 2 pi k. Okay, and here's another example. Let's find all the solutions to this equation. Now, instead of graphing it, let's just use complete algebra. So if we had sine of x here plus radical 2 equals negative sine of x, my variable, or my unknown, is actually sine of x. So I want to isolate sine of x to get my answer. But first of all, I need to combine them, just like if they were x's. So I'm going to add sine of x to both sides. So I'll get 2 sine of x. I wish I wouldn't use x in these cases. Often we prefer to use theta for angles, but that's the way it goes. Plus radical 2 equals, and this would equal 0. Now I want to isolate my sine of x. So first I'm going to get rid of that square root of 2. So I'll have 2 sine of x equals negative radical 2. And then divide by 2. So I don't think I have a lot of room here. So I'm going to go up here. And that will give me, since these two canceled, sine of x equals negative radical 2 over 2. I want all the solutions. So let's keep that in mind. Let's go to my unit circle. Now my sign is negative in quadrants 3 and 4, so I don't even care about the top two. So negative radical 2 over 2, oh, that's this one right down the middle and this one right down the middle. So that's going to be my fourths. So this is 4 pi over 4. So this one's going to be 5 pi over 4. And this one is 6 pi over 4. So this one will be 7 pi over 4. So my two answers are 5 pi over 4 and 7 pi over 4, but I also want all of the coterminal angles. So I'm going to add 5 pi over 4 plus 2 pi k, and I'm going to take 7 pi over 4 plus 2 pi k, and that is what gives me all of my answers to the equation. So I would say my answer is right there. And I could check this graphing, and you can always check it by graphing. Okay, now let's go on to a little twist here. When we have multiple angles, we have a different period. If you go back to review when we graphed the sine of x versus the sine of 2x, well, that changes the period because the period is 2 pi divided by b. On this one, the period is 2 pi. But on this one, the period is 2 pi divided by 2, or pi. So that's going to change our answers on these types of problems. So let's see how we go about finding the solutions to the sine of 4x is equal to 1. All right, so first of all, I'm going to think of this as, well, the sine of what angle is 1? And so I know that that angle, if you think about the sine, that's the y-coordinate right here. I know that that angle is actually pi over 2. So I know that the sine of pi over 2 is 1. So that means that 4x, oops, go a little bit thinner. So I know that 4x has to equal pi over 2. But I also have to take the period of the sine. So that's plus 2 pi times however many in this case, because we want all of them. There's no restriction. So what I did is I said, well, the sine of pi over 2 is 1. So that means that 4x has to be equal to pi over 2 plus any angle coterminal with pi over 2. Okay? So now I have to solve for x. So I'm going to divide everything by 4, or algebraically, timesing everything by 1/4 is the same as dividing by 4, but it'll help me with my fractions. So I'm going to times 1/4 by 4x. So I'm going to distribute this 1/4 to here, and to there. Okay, so what does that give me? 1/4 times 4x gives me my x. Hello, yes, that's what I want. Okay, but what's 1/4 times pi over 2? Pi over 2 times 1/4. And then I'm going to have 1/4 times 2 pi k times 1/4. Okay, so let's simplify these out. So this becomes x equals now pi over 8 plus, and the 2 and the 4 will cancel, and I will get pi over 2k. Okay, so that means that my answer is pi over 8 plus pi over 2. Okay. And again, we can check that with a graph. So let me just summarize this. When you have a multiple angle, you take your multiple angle and set it equal to the value that you know has a sine of 1. So basically, sine inverse of 1 would give me pi over 2. And then I would take that value, and don't forget to add the period for the function. Let's do another one of these. Okay, this one's a little bit different because we have tangent. So we're solving this equation for what value, and so x, what value? 3 times the tangent of 2 times x plus 3 equals 0. Okay, so first of all, let's isolate my variable, which is now going to be the tangent of 2x, which is some angle. We need to find x. Okay, I'm writing angle, but theta, that's going to equal 2x. All right, so first of all, let's minus the 3. And let's divide by 3. So we can get the tangent of some angle is -1. Okay, so now let's look at our unit circle. And the tangent, to be -1 means that since the tangent is y over x, they have to be equal. And they can't be in this or this because that's where the tangent is positive. So we're looking for an angle right here and right here in quadrants 2 and 4. And those angles are fourths. And this one happens to be 3 pi over 4 and 4 pi, 5 pi, 6. This one is 7 pi over 4. So my two answers are 3 pi over 4 and 7 pi over 4, but also every angle that is coterminal with that. So let's take 2 of x. So this needs to be 3 pi over 4. So we're going to say 2x, which is what's inside my argument. That's the argument is what's called after the tan. That must equal, oops, let's get that over, must equal 3 pi over 4 plus, and if we think about it, this period of a tangent is actually pi. So we're going to go with pi times k. And that's going to cover my 7 pi over 4. So in this case, I don't have to do the 7 pi over 4 because that automatically is in my period. If I get all the angles that are in my period from pi. So that will give me this one, and then the next one will give me that one, and then the next one will give me that one. Okay, so all I have to do is solve for x. So I'm going to times everything by 1/2 to get rid of that 2. So again, I'm going to distribute here and here and here. So 1/2 times 2x gives me x. Yes, I like that. 3 pi over 4 times 1/2 is my next value plus, and then I want pi k times 1/2. All right, let's simplify this up. So x is going to equal 3 pi, that's going to be 3 pi over 8 plus, and this one looks like pi over 2k. And that should give me all of the values of this. I'm going to stop the video here and take a break, and then we'll continue on the next video.